Okay, so we're asked to plot the point here in polar coordinates. Now, when we look at polar coordinates, it's always r first, the radius, followed by the angle. And generally, when we do these, we'll be doing with our angles in radians, especially later on when we bring in some calculus aspects. We'll mostly be doing here again with the angles in radians. Although sometimes you may see them expressed in degrees just for the sake of clarity. So what I usually do when I'm doing these, especially if I'm just plotting a single point like this, is I would just use I'll just kind of sketch a polar graph paper, some polar graph paper. Polar graph paper usually consists of, at the very least, your polar axes, and then circles with dashed lines to represent the different distances from the pole. So that way we can look at this and say, hey, we're a distance 2, so we would be on the circle of radius 2 from the origin. Okay. And then my angle is pi over 3, so we would form that angle with the positive x-axis. So with those ideas in mind, remember pi over 3 is 60 degrees. So I'm going to go with my polar axis here and form an angle of about 60 degrees. But again, nobody's going to make you get a protractor out here and do this perfectly. So the approximate angle is fine, and it's crossing at the 2 lines, so there would be our point. Let's call it letter A. So that's one way to represent that point, right? Is 2 pi over 3. And there it is on the graph. That's the only way to graph it. Sorry, Matt said that wrong. Now we're looking at these alternative forms for the point. And so we just use these ideas above. And I'm just going to use these two, the same exact two. The idea that I can find something coterminal. So I could take my angle of pi over 3, and I could say, hey, we could measure that clockwise and have the angle that way. Or we could measure all the way around and stop there. All right, that's 2 ways to do the problem. So I'm just going to go ahead here and say, let's just deal with the move around a second time. So we would just have pi over 3 plus 2 pi. All right, and that would be 2 1/3 or 7 pi over 3. So a second way to write the point would be as 2, 7 pi over 3. Okay. Now we could go on and add another 2 pi on or subtract off 2 pi. That would get us a second one. But I also want to emphasize this negative point idea. Okay, so remember the way the negative point idea works is you're going to be heading in the direction that is the opposite direction of where you're currently pointing. So, in other words, we would be heading in this direction. And then we would travel a distance of -2 to get us back to this point. So we would face this direction, but we're going to go backwards 2 units to land on that circle. Okay, so we just need to measure this angle. We just need to measure this angle here. Well, what we realize is that angle is just your original angle, pi over 3, plus a half turn. Plus a half turn, so add pi onto it. Pi plus pi over 3 would be 1 1/3 or 4/3 pi. 4 pi over 3. Then we could write that down as -2, comma, 4 pi over 3. Okay, let's look at a second example here. Let's plot the point -2, comma, 5 pi over 6. And once again, we're going to want to graph it. And then we're going to want to find 2 versions that are equivalent to that. 2 versions that are equivalent. So I'm just going to paste in my graph paper from before. Again, I'm 2 units away, so I'm going to be on the circle of radius 2 from the origin, from the pole. And then this time I'm going to be facing in a direction 5 pi over 6. Then I'm going to go backwards along that direction. I'm going to go backwards along that direction. So I'm going to be facing in a direction 5 pi over 6, or 150 degrees. That would be going in this direction. Say something like that. All right, and then I'm going to go backwards 2 units. So what I would do is just trace backwards through that point. Let me just get my dotted line here. Trace backwards until I hit the circle of radius 2. So therefore, my point B would be right there. All right, and then we just want to look at alternative ways of writing that point. Alternative ways of writing that point. Well, we can keep the same direction and just modify our angle. So last time I went ahead and went around a second time. This time I'm going to measure it backwards. So I'm going to measure clockwise. Since that's 5 pi over 6, and I know a full turn is 2 pi, we can think of that a couple ways. It's just 5 pi over 6 minus 2 pi. Or I'm actually going to think of it this way. Since that's 5 pi over 6, I know that little angle there is pi over 6. And then I have a pi on top of that. So pi plus pi over 6. So one way that I can do that is by measuring it as negative 7 pi over 6. Negative 7 pi over 6. All right, and the idea here again is I'm just taking and measuring off the fact that that angle is pi over 6 and then pi more. So the whole way from here to here would be 7 pi over 6, but it's clockwise, so it would be negative 7 pi over 6. Okay. The second way, I'm going to use a positive angle, positive distance 2 here. So I'm actually going in the direction of my point, and since I've just recognized that this angle is pi over 6, then I know this angle here is also pi over 6. So I could actually write that as negative pi over 6. Okay. So here's a little bit about plotting points, and also recognizing versions, other order pairs that would actually land us at the same point. Okay.